All right, so to do number 65 in 10.2, thanks Candace for random guessing. All right, we have this table. So I trust that you all can either read this or look in the book for the table in number 65. And it says, part A, is f of x invertible? If not, explain why. If so, construct a table of values for f inverse based on blah, blah, blah. Okay, so what do I need to check?
If multiple inputs give you the same output.
Good. I'm checking for 2 inputs to give me the same output under the rule f. So, are there any f outputs duplicated?
No.
No. So, f is invertible, right?
G, however.
And how, yeah, g's maybe a different story. How do I make a table for f inverse?
You just flip the table upside down.
Yeah, flip these 2 lines upside down and recall the bottom one f inverse. So for instance, if I'm going to do f and f inverse of x, right? This first thing tells me that under the rule f, negative 3 goes to 9. So under f inverse, 9 input goes to negative 3 output, right? It just does this backwards. So
7 input gets you negative 2 output.
perfect. So negative 2 goes to 7 under f. So 7 goes to negative 2 under f inverse. And so forth. So the next line is 6, negative 1. The next line is negative 4, 0. And fill in the rest. You guys okay with that?
So you've explained this a couple of times. All inverses, you're just going backwards on the line.
Uh-huh.
That's all you're doing. Okay.
Yeah. Really, the only idea is I've got a function f that goes from
Yeah.
left to right.
And then you go from right to left.
And then I'm wondering, is this thing that goes backwards actually a function? Right? So a function is a rule that takes inputs to outputs and has each input going to one and only one output. And when I flip that over, I have to wonder something about, does each output correspond to one and only one input? So that's that horizontal line test thing, or me just checking. So what's part B? B, same question for part A, or for the function g. So is g invertible?
No.
G isn't invertible. Why not?
Because 9 multiple 6 would be multiple.
Yeah, because 9 goes to 3 and 6 goes to 3. Oh yeah, and also negative 9. Is it important that I have all 3 of them?
Yeah.
Not really. As long as there's 2 inputs that go to the same output, you know this thing doesn't pass the horizontal line test. Okay.
It's like getting an F minus. You already failed, just failed worse.
Yeah, exactly. You guys cool with that? Okay, so G is not invertible. What's C say? Make a table for h of x is f of g of x. Okay.
So you have to follow the pattern.
H of x is f of g of x, right? That's what they asked me for?
Yeah.
Yes. Okay, so my x's and my h's, right?
Okay, so the x's are going to be the same. It's going to be negative 3.
So I'm going to do this to the same x's. Now, where does negative 3 go under, which rule am I doing first?
G.
G first. Okay, so negative 3 goes under rule G2, positive 3.
And then
And then that go to negative 9.
And then I feed that into f, so I get negative 9 out.
Wait, what? Never mind. Gotcha.
Cool? So really, I'm thinking this negative 3, right? First under G, it goes to positive 3, and then that goes to negative 9. So where's negative 2 go under G?
1, so it's negative 5.
To 1, and then 1 under F goes to negative 5. -1 under G goes to
3.
3, and I already know where 3 went. That went to -9.
Uh-oh, it's not a function.
It's,
Well, it's not a.
Not invertible.
yeah, it's not invertible. It's still a function, right? But it's not an invertible function. And how was I going to be clued into the fact that this thing wasn't going to be invertible?
Because one of the pieces wasn't invertible.
Yeah, it's made out of a composition of functions. One of the pieces wasn't invertible. That's not a guarantee, but it's,
It's a clue.
yeah, I mean, this is like,
Cheating.
no, I mean, this is like, it would be exceptional if it was actually invertible.
Oh,
So if one of the pieces isn't invertible, it's almost certainly not invertible, but it's possible that it is. You guys see that? Okay. I assume you guys can fill in the rest of the table? No? Okay, good talk. And part D. Oh, explain why you cannot define a function j by the formula. So j of x is g of f of x? Question mark, question mark? Like, why could I not make such an object? No. Nice try. That was a good try. So why can't I make a function g by doing, or j, by doing f first and then g?
You don't have the set inputs for g of x with that?
Good. When I try to plug -3 into that thing, right?
You have to go through h of x.
I go through f, I get 9, and then I don't know how the hell to put 9 into the function g. You guys see that?
No, because there's no
I just don't know what to do with that. It doesn't make any sense. In fact, actually, none of these numbers here, right? None of the f that outputs fit into the rule g at all. You guys see that?
Yeah.
That's like me trying to draw a function diagram that looks like this. Here's f, it goes over here, and then g just lives over somewhere else. You guys see that? And actually, worse yet, I do know where g goes to, right? You guys see that? These guys? Those are all in this beginning set. So g doesn't really just go any old random place. It goes into there. Right? It goes into part of the domain of f. Not all of the domain of f, but part of the domain of f. You guys see that? What's in this stuff that's not
The numbers that don't duplicate.
close? So what's something that's in the domain of g that's not in the range of f?
0.
0, for instance. How do I know that 6 isn't 1? Because 6 isn't in the domain, right? The domain is the counting numbers between -3 and 3. And range of g is, well, I mean, we could just go look, right? It's got 3 and 1 and 2 and -3 and doesn't have -2 either. Oh, it does have -1 though. So this blob out here is made of 0 and -2. And this blob in here is made of everything else. You guys see that? That's important that the domain of the first, or the range of the first function fit into the second step. Otherwise you can't execute this thing. Cool?